up there. And another radical. And then let's do one where we're going to find the equation with tangent line. Okay? Let's see how you do. Ready? Here's my first one.
Now, if it is a just log base 10, that's also 1 over x, right? Derivative?
That's right.
Okay.
Oh, whoa, I'm sorry. I apologize. I just heard what you just said. You said log base 10.
Uh-huh.
You will rarely see those. Okay?
Okay.
You will rarely see those. I want to show you something. Have you ever heard of they call it the, what's it called? Someone had to find this on a calculator. I'll give you an example. Do you know there's a way you can find out with a calculator?
Yeah, log of 7 divided by log
Divided
of
by log of 5.
5, yeah.
And so, and what I'm going to show that to you. You can think of this as log of 7 over log of 5. That's going to help you remember this already. So if you had to calculate, I'll just get this out of the way. You had to calculate log base 5 of 7.
Uh-huh.
And you go, well, I have my TI-83 calculator here, and it's only got a log base 10 button and an LN button, right? I can write it like this and type it on my calculator like this. These have base 10s.
Uh-huh.
I didn't know if you knew this, Art, which is kind of cool. This is also equal to the ratio
Log 7.
ln of 7 over ln of 5,
Yep. Uh-huh.
right? So, if log base 5 of 7 is log 7 over log of 5, and you and I had to find, like, let's say they had a function like this. Log base 10 of 2x plus 2. And you had to find a derivative. Everyone, you don't have to copy this unless you want to. Because log base 10s do not come up often. You get a ton of LNs, the log base 10s do not come out that often. But if you're curious, feel free to write this. To do this, I want to use that, so you want to rewrite this with LNs.
Gotcha.
So see if you can do it. And what's a way I can write this in terms of LNs?
So ln
That's
2x,
equal to ln of
2x plus 3,
2x plus 3 divided by the constant natural log of what number?
10.
So the bottom line is this, if this helps you out. If you ever have the differential, the log base 10,
Uh-huh.
just divide by the ln of the 10 and do the ln of 2x plus 3.
Got, is
Isn't that
ln of 10 is 1, right?
Oh no, ln of e is 1,
E is 1, okay.
right?
L
Ln of 10 is irrational.
irrational.
It's some goofy, long number. He's got the TI-83 right there. But guys, what's ln of 10 off that thing? Hit a natural log of 10. It's some irrational number.
No, I was thinking if it is like log base 10 of 10, then it's 1.
2.30, right?
Yeah.
So that's what you have to do. You just simply divide by that. Every time. So every time you do a log base 10 derivative, do the natural log derivative, and then also divide by what?
Natural.
ln 10.
10, that is, gotcha.
That cool?
Yep.
You won't see many of those, I don't even know if you'll see one. I might have signed one just to make sure people know. All right, give this one a shot. 1 plus 8 e to the 2x. Whoa. Can you differentiate that?
Yep.
And then after this, I'll do a tangent one. We'll crash out of here early. Sound good? So 2 more. Try that one. What do you think, Josephine? All that to what power? Oh, and here's another one, Sarah. I didn't have any parentheses there. But there's no where's the parentheses? What's the G?
Oh, 2x.
No, the 1 over
It's
1
more. It's more. It's everything under the what?
square root.
It's everything under the radical. I know, right?
Yeah, I got it.
But see, now we've built up to this point where this stuff under the radical is pretty big, huh? So first, I'm going to think all this to the what? So half in front, decrease all this by what? And so where's the G? All this is my what?
G.
Here's my G. So what's the only thing I need left over? G prime, right? That's what I'm curious if you can get. You got to get the derivative of all that. Well, what's the derivative of the 1 part? What's the derivative of constant?
8.
0.
Oh,
right?
0, sorry, yeah.
You want to agree? Let me make sure. Where that is, 0, plus,
82x.
and we're okay with that? That's 0?
Yeah.
You're good, and then plus, but we gotta differentiate that. Well, do I need a product rule in here?
No.
What do y'all think? Josephine, do I need a product rule in here when I'm doing G prime? No, because what's in front of e to the 2x? It's not an x, it's just a what?
Constant.
8, it's a constant. So let that 8 stay there. And tell me how you do this derivative. It'd be 8 e to the 2x times
2.
2. So do you see this? It's like we're doing a problem that needed chain rule, but then when we take the derivative of this, we need to apply chain rule again. That's what we mean, like it's like a double chain problem, right? Do you see it, Josephine? Or she's not. Here's what I did. Here's my original big G right here, right? Look at all this. This is the big G. 1/2 in front. Decrease all this by what? 1. Great. Now I gotta multiply what? G prime. So you gotta get the derivative of this. But we've gotten derivatives. We did a problem just like that earlier today. Do you remember? It was just like an e to the 4x. What was the derivative of e to the 4x? 4 times e to the what?
4x.
4x. So what is the derivative of the 1? 0.
And the 8 doesn't affect that?
It's the constant. And by the constant rule, the 8 will just what? It'll just hang out. It'll just hang out. So let that 8 hang out, and you're going to go 8 e to the 2x times what number? 8 e to the 2x times what's
2.
that change? Which makes it what?
Not 16, there is a 2 over there. So,
That's right. So what's this final answer here?
so 8 e to the 2x divided by 1 over 8 e to x square root.
What do we get? 8
Uh,
e to the 2x. Anything cancel?
yep.
Those 2's go out, right, everyone?
Mm-hmm.
All over? Square root of?
1 plus 8 e to x.
Let me make sure, does everyone agree?
Yep.
Does everyone see it?
Where do you get the 2 from?
Ah, right here, watch this. In this problem, we did a chain rule and then there was another chain. I just didn't write it out, but as we're sitting here, all you and I had to do is get this derivative. You go, all right, I think that's a 0. But how do I differentiate this? The 8's just the constant, so the 8's just what? Stay there. How do you do a derivative of e to the 2x? It's not just e to the 2x, is it? How do you do the derivative of e to the 2x? You again need what rule? Chain rule. So what's the derivative of e to the 2x? 2 times e to the 2x, right? E to the 2x times the 2, the chain. Does that make sense?
Yeah.
But that's why we're saying this problem is like, whoa. When I started out, I was doing it, I thought this was my G, and then it was almost like I had like an H up here, and I had to do the H prime thing. Cool.
So the G prime of 1 plus h to the 2x is that?
It's 8 e to the 2x times a 2. She's not seeing it.
Why are you multiplying?
I know why. And what's the derivative of that? I can slowly bring it through here. What's that derivative? It's just not it. What's the derivative of that? E to the 4x times a? Times a 4. Chain rule. Right? Here, let me do another one. I just gotta take you in there. So we'll get you there. Try another one. Ready? What's y equals e to the 6x? What's that derivative? That'll be e to the 6x, that's f prime of g, times, what's the derivative of 6x? 6. So far so good? Yep, oh good. Now I got a 5 e to the 6x. And you gotta get the derivative of that. What's the derivative? It'll be e to the 6x times a 6, but what do we do about this 5? What do you do about the 5? Just let it stay there. So the 6 times the 5 became a what? 30. And then one more. I went, how about a y equals 1 plus 5 e to the 6x? How do you differentiate that? Well, the derivative of 1 is just what? 0, but what's this become? This would be 5 e to the 6x times a 6, 30 e to the 6x. So that's what was going on there. Right inside there.
But if that one had like an X or something, then it'd be something different.
Yeah, did you say like an X right there?
No, like right with the one, or if it was like.
Oh, you're right. Hey, watch this. I'll put it and then I'll erase it. You said, what if this was an X? Ready?
Mhm.
Psst, psst. All right, then what would I have to squeeze? Think we got enough room here, Amber? Get the squeeze right there. What's that derivative? 1, then a plus. The only thing is, I don't think we could write it like this. Because now look at it. You see? Yeah, and we couldn't write it like that. Cool? So when that was Amber's problem. We'll end on Amber's problem. Hey, as you're leaving, can I give you a chain rule just to play around with over the weekend?
Yeah, sure.
The only thing is, everyone, I didn't write out the answers to the back, so if anybody wanted to try all these, and then you could tell me the answer key, would that work? Key Bell Raj, that would be a good bonus. You give me the answer key to these? I didn't write them. I got too tired when I finished this, so I never put out the answers to this. So on one side is chain rule, the back side is just, hey, when do you need chain rule? Students always ask, well, I don't know when I need chain rule. And so I give like 23 problems on the
Thank you.
back of this thing. Remember, they're on the back. So you can do this. Hey, you sent me an email, didn't you? I didn't get a chance. Today was so crazy, I didn't get a chance to read my email. So I'll get to it tonight. All right. Cool. Everyone on that, and next class, I'm sorry, we're just gonna have to do some more chain rules, is that all right?
Yep.
I'm serious. You do not move past this rule until you got it. Oh, hey, thank you so much. I'm not gonna move past this rule till everyone smokes this rule. You got it.